If you've watched my YouTube channel before, you probably know that I am a huge fan of 3D printing. I love the fact that I can design something in my garage and print it and just use it and not rely on anyone else to get the fabrication done. 3D printing has a ton of advantages over standard manufacturing practices, but one of the biggest downsides is that it takes forever. Even using a 0.8 millimeter nozzle, my 3D printer runs all the time and it never seems to keep up. So to help combat this, I run my 3D printers at night, which I'm sure a lot of you also do. Now, 3D printing technology has gotten a lot better than what it used to be, but still I don't feel 100% comfortable running my 3D printer while I sleep. So one thing to help alleviate my fears is one of these. This is called an AFO ball, or automatic fire off ball. And what this is basically a giant firecracker surrounded by extinguishing powder. So if there's ever a fire, it'll catch this on fire and this will explode like a small bomb. And it'll put out the fire using the fire extinguishing dust surrounding the explosive core. This was really cool. I saw it online and I had to buy it. So when I do run my 3D printer at night, I used one of the AFO balls. But I was thinking about it, and really that is a temporary fix or not necessarily a complete solution to the problem of a 3D printer catching on fire. So let's say, for example, your hot end catches on fire, and then the AFO ball explodes, puts out the fire on your hot end. Life's good. Well, what if the hot end still has power and catches back on fire again? What's to stop that from happening? Nothing. I mean, Marlin, like I said, does have some software stuff put into it, but let's be honest. Some of the most popular 3D printers are made in China. And I'm a big fan of my Ender 3, but I don't really trust the engineering that's put into them to keep myself and my family safe while I'm asleep at night. So I decided to try to make something that would automatically shut off power to my 3D printer in the event of a fire. Before I get too deep into this, I know I'm going to get a lot of flack for it, but I am not going to be providing the files, the Arduino files or a wiring diagram or anything like that that goes along with this project. This project was purely for myself. I know that sounds a little selfish, but the reason I'm doing that is because I know that there are a whole bunch of qualifications and a whole bunch of ratings that true fire protection devices need to follow, and I don't know how to design to those, and I am not qualified to make anything like that. So just remember, I'm a guy in my garage making this. If you want something like this professionally, I do believe that they make a smoke detector that can control a receptacle. So that's something that you could buy, and then also you can buy one of these too. You know, it's not like I made this. So you could get a similar setup to what I have by buying things that are hopefully UL rated and made by someone a little bit more professional than me. So without further ado, let me show you what I came up with. The automatic shutoff device that I made has a few key components. First, an LCD display, some analog temperature sensors, and you could use digital ones too if you like, but these are just Arduino compatible analog temperature sensors, nothing crazy. We have got an MQ2 gas sensor, and these MQ2 gas sensors are really made to detect things such as butane, natural gas, I believe, and alcohol vapor. They do work for detecting smoke, but they're not as sensitive as, let's say, a smoke detector in your house. So keep that in mind. I did get an MQ2 sensor with a built-in breakout board, and this is just nice because it's easier to hook up to my Arduino. So we got that. And the heart and soul of this whole project is a clone Arduino. I think this is a nano clone, and that's what I did all the programming on. This is what the automatic shutoff device looks like whenever it's powered on. So I'm going to kind of walk you through the LCD real quick, and then I'll explain what all these buttons do and knobs on the side. So this number right here where it says gas, that's actually the amount of particulate inside of the enclosure that's detected by the MQ2 sensor. This G max is the maximum amount of particulate that MQ sensor has detected since the device is turned on. And the minimum is, again, the amount of particulate
that the minimum amount of particulate that the MQ2 sensor has seen since it turned on. So these just kind of help you get an idea of what your enclosure is doing, so you don't have to constantly keep looking at it. Over here, the G set, that is the set point. So if your gas number goes over this G set point, it automatically kills your 3D printer. So that's kind of the heart and soul of this whole device. Down here where it says temperature or temp, that is the temperature of the enclosure detected by our analog sensor. The max F is the maximum temperature inside the enclosure that it's seen since it's turned on, and min temp is the minimum temperature that the enclosure's seen since this device has been turned on. Over here, this is what I call, this toggle switch is what I call the standby toggle switch. So right now we are in what I call away mode. So whenever this toggle switch is in this position, the light comes on and we're in away mode. That means that if the amount of particulate goes over this G set number, it kills our 3D printer. But if I put it in standby mode, the light turns off. And now, if that G set number, or the gas number goes over our G set number, it doesn't matter because it's in standby mode. And that's really useful whenever you're cleaning off your 3D printer bed or doing some maintenance in there, and you might use alcohol or something, and that really, alcohol messes with the MQ2 sensor. It really makes it go high. So you don't want to accidentally trigger your 3D printer to shut off if you don't need to. So whenever I'm in the shop next to the 3D printer, I put it in standby mode so I don't accidentally have any auto shutoffs. Another good thing about this being in standby mode is that you can use this potentiometer and to change your gas set point. You can't do it when it's in away mode. As you can see there, now this G set number is set. It won't move. You can only move it when it's in standby mode. And then once you get the set point to where you want it to be, let's say we want it to be 115, and you press this button over here, the yellow light pops on, and now whenever you go to away mode, your G set is now at 115. Let's say, for example, we want it to be lower. We can move it down while we're in standby mode. We program it, move it into away, and as you can see, the G set stays the same, and then look, we've got a trigger because it said that the gas is higher than the set point. So whenever this happens, as you can see, I've got these LEDs up top, and whenever the gas set point is, or the gas is less than the set point, the green light's on. Whenever the amount of gas in the enclosure is within about 5 or 10 of the set point, I don't remember how I programmed it, to be honest, the yellow light comes on telling you that, hey, you're getting close to your gas set point. And whenever your gas goes over your set point, as you can see, this red LED starts pulsing, letting you know that the device has tripped. Also, there's two ways that this device can trip. It can trip from having too much gas inside of it, or also a temperature, too high of a temperature. So I have it set right now, if the enclosure sees a temperature over, I think I've got like 130 degrees Celsius, then it'll automatically shut off due to a temperature issue. So down here, as you can see, it now says gas. So this lets you know that yes, the device is tripped, but it's tripped because of the gas sensor. Now, if it was to trip because of a temperature problem, it'll say temperature at the bottom, or temp with an exclamation point. So you know why the device tripped. So let's say the device is tripped. We want to reset it. So we're gonna go to the standby mode, change our gas set point to something a little bit more reasonable. We'll set it. And then we flip it on standby mode, but you see the standby mode light won't come on and it's still tripped. So I made it so you have to physically reset the device so it doesn't automatically reset itself and you don't have any unintended resets. So you have to press this button right here and that resets this whole device. So now the 3D printer would turn back on. So this is the control panel in a nutshell. I apologize if the audio is a little bit echoey. Right now the camera is inside my 3D printer enclosure, but I wanted to show you this device. So if the control panel is the brains of the operation, this is the brawn. So let me explain what's going on. This wire right here is actually 120 volts from a plug that comes into this junction box. There's also, and you probably can't see it, but there is a 120 volt to 5 volt DC converter that takes 5 volt DC and sends it out through this black wire up to my control panel. So that's how the control panel is powered. And not only does this black wire send power out, it also sends a signal from the control panel back down to control this solid state relay, which I have on the side. The output of the solid state relay then goes to this wire, and it can toggle power on and off to the 3D printer. On the side here, you'll notice there is a heat sink. These solid state relays get kind of toasty whenever they have a lot of load going through them. So I cut a hole in the side of the junction box and put a heat sink on the back to help dissipate the heat, and it's worked really very well. So this is the final piece of the automatic shutoff device's puzzle, let's say. This is my sensor. So we've got our MQ2 gas sensor in here, and then also inside this is the analog temperature sensor. This wire then is routed back to the controller, and that's where 5 volt DC is routed this way, and then we've got the analog output from the MQ2 sensor and the temperature sensor running back out. So pretty straightforward. So to simulate a fire, I'm going to build a small fire inside of this Smucker's strawberry jelly can, or jar. And to light the fire and to use the fire, I'm going to use something called fat wood. So I've taken that and I've broken up into a few pieces. I'm going to throw these and some paper towels inside this jar, light it on fire, and let's see what happens. As you can see, the gas sensor has triggered the device, so the standby light's off and the 3D printer is powered off. So let's just let that go down a little bit, get the smoke out of there, and reset it. All right, so now let's try the heat test. And for the heat test, I'm just going to use a hot air gun because that's probably the easiest thing to do. There you go. That also killed the power. And we'll let the temperature go down a little bit. Reset it. Good to go. So in summary, I hope that this video gave you some ideas of safety devices you could add to your 3D printer. I want to thank you very much for watching. Have a great day.